morning students, this is Junita Mukherjee from SS Public School. Today we are going to start this new chapter, that is electromagnetic induction. In this electromagnetic induction chapter, this is the sixth chapter of class 12th physics, and here we have discussed already about this electromagnetic induction in the smaller classes. So in the smaller classes, what is electromagnetic induction? You know very well about it. That is, it is a getting of the currents, induction induced currents from the magnetic field itself, which is induced by the magnet and some number of coils, or taking a solenoid into consideration. So whenever there is a solenoid and there is a magnet near that particular solenoid, that solenoid will bring it towards this solenoid, or maybe away from the solenoid. This particular thing will be like this. That is, this is the solenoid itself, number of coils here, and this is the magnet itself. Whenever we bring this magnet towards the solenoid, there will be a deflection in the galvanometer which is attached to this particular solenoid itself, and this induced current which is there because of the magnetic field itself. So this particular thing is what we call the electromagnetic induction. That is, magnetic lines are magnetic field is produced, or magnetic field is brought near a solenoid. There will be induction of the current in the galvanometer, and the galvanometer will show the deflections in the galvanometer itself. So this is what we call the electromagnetic induction, and here we have Faraday's law and motional electromagnetic force. So phenomenon of generation of the current or EMF by changing the electromagnetic field is known as EMF, that is electromagnetic force itself. So Faraday's has given a law, suppose a loop in which it has been given. So first of all, we will discuss something about this electromagnetic force, that is EMF, the phenomenon of generation of the current or EMF by changing the electromagnetic field is known as EMF. You know it very well. This is the electromagnetic induction, or the what we call the electromagnetic force is induced in the current itself, and whenever this particular force is being away from this particular solenoid, there is no current passing through this galvanometer itself. So this is how this electromagnetic induction works, or the electromagnetic force is there in this particular circuit itself, and thus the electromagnetic force is generated. Now, electromagnetic flux. The magnetic flux, this here, what is explained here is that the magnetic flux. What do you mean by magnetic flux? First of all, whenever the magnet is bring inside a particular magnetic field, that field there is a number of field, or the number of the magnetic line passing through that particular area. So this particular field is what we call that this thing is what we call the magnetic flux itself. So here we have, suppose a loop enclosing an area of A is placed in a uniform magnetic field B, then the magnetic flux through the loop is given by phi B is equals to integral sin of P dot dA, as we know that very well. Now the magnetic field pi perpendicular to that of the plane of the loop, then the magnetic flux will be phi B is equals to dA, which is maximum value. First equation we can take like this. This means that B is equals to phi B itself. That is, the magnetic field strength is the magnetic flux per unit area, and is called the magnetic field flux density, or the magnetic induction we can take. Okay. So when the magnetic field B is perpendicular to that area, rather it is inclined at an angle theta with respect to the normal to the surface, or the magnetic flux becomes phi equal to B dot A, that is B A cos theta. Mod A mod B cos theta, or it may be given as B A cos theta, same equation, where theta is the smaller angle between B and A. If an angle is parallel to the magnetic field, then there is no field line passing through it, and the magnetic field link with the plane will be zero itself. So whenever the plane is parallel to the magnetic field itself, there will be no magnetic flux linked with that plane, and it will be equal to zero itself. So in equation number 2, it is very much clear that the flux can be varied by changing any one by or more of the term B, A and theta. The flux can be altered by changing the shape of the coil, by stretching, or by compressing in a magnetic field by rotating a coil, or in a magnetic field such that angle theta between B and A changes. So here we have taken a magnetic field here, and thus the n cap, this is the unit vector here, and the angle is taken as theta in 90 degree, and therefore the magnetic flux will be given by phi equal to phi B is equal to 0 itself. So because it is 90, it is perpendicular to it. B is the magnetic flux here, that is B is the magnetic theta B is phi B is the magnetic flux here, and B you know it very well, that is the magnetic field itself. Okay, and phi B is equals to 0 here. So the SI unit of magnetic flux phi B is Tesla meter square, which is also known as Weber, and 1 Weber is equals to 1 Tesla meter square. 1 Weber is the amount of the magnetic flux over the area, that is 1 meter square, held normal to the uniform magnetic field of 1 Tesla, and 1 CGS unit of magnetic flux phi B is maximum, is Maxwell's mx, where 1 Weber is equal to 10 to the power 8 Maxwell. That is the SI unit of magnetic field flux will be ml square t raised to minus 2, and t raised to minus 2 a raised to minus 1. It is a scalar quantity, and hence the magnetic flux becomes BA cos theta is equals to the second equation, which is given by the plane where it is parallel to the maximum magnetic field. There will be no field acting on this particular thing, and the magnetic flux links with that particular plane will be equal to 0 itself. And from the equation number 2, it is very much clear that any one term, that is B, A and theta, can be changing, and the flux can be altered by changing the shape of the coil, by stretching it, or by compressing. We can change the flux here, and thus the rotation of the coil in the magnetic field is being done by angle theta B and A. So B and A can be done by changing. By changing, we can value the value of the magnetic flux linked with the coil will be changed, and thus this particular thing, that is Faraday's law and motional electromagnetic, that is magnetic flux itself, I have explained you well through this particular example. So we have already discussed the magnetic law of motional electromagnetic force and magnetic flux in this particular chapter. So moving towards for yet another topic for this particular chapter, that is electromagnetic induction, in the next video. Till then, thank you students.